All right, so section 1.5 is on infinite limits. So the first thing I'm going to do is I'm going to look at a couple different limits using a table. And the reason that I'm doing a table is, first of all, there's really not a way to simplify or algebraically solve this limit because I can't plug in 2 and I can't simplify it at all. And second of all, there are two different limit questions here and they are both one-sided. When you do an algebraic limit, it's only a two-sided limit. And in order to investigate only one side of a number, you will have to plug in values on that side of the number. So I did set it up like a two-sided limit with this double table, but I'm gonna not look at this part for now. And I'm only going to do the limit as x approaches 2 from the negative side. The negative side is a little less than 2, so I pick numbers a little less than 2, and I'm going to plug them into the function given. So we'll start with 1.9. And I got negative 30. Then I'll plug in 1.99. Got negative 300. And then 1.999. And negative 3,000. Now I can't plug in 2. But what is the limit? What are these numbers approaching? Well, they're just getting more and more and more negative. So I would say this limit approaches negative infinity. All right, now I'll do this next limit. Again, I'm not gonna look at this part, I'm only gonna do this part. So this is the limit as x approaches 2 from the positive side. So I picked a number a little bit bigger than 2, a little bit bigger, and I will plug them in here. I got 3,000. I got 300. And I got 30. So as we get closer to 2 from the right-hand side or from the positive side, these are getting bigger and bigger and bigger. So I would say this limit approaches infinity. Now, if somebody were to ask me, which nobody did, but if somebody were to ask me, the limit as x approaches 2 of this function, I would say does not exist because on one side it's approaching negative infinity, on the other side it's approaching positive infinity. It is not approaching a single value, and so from both sides it would be d and e. All right, different question here. I have used the table to estimate the limit. The limit as x approaches infinity of 1 over x minus 2. So I have to pick numbers that are getting close to infinity. I started with 1 and then I just increased until I got to 100,000. If you wanted to go to 1,000,000 or 1,000,000,000, you could continue going, but I think going to 100,000 is really going to give us what we need to solve this problem. So I'm going to plug 1 in for x. So 1 divided by 1 minus 2, and that was negative 1. Then I'll plug in 10, 0.125. Plug in 100, 0.0102, plug in 1,000, 0.0010, plug in 10,000. This I am getting scientific notation. It's 0.0001, plug in 10,000, again, scientific notation. And so you can see that these numbers are getting teeny, 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 tiny, and I would say the limit as x approaches infinity is getting very close to 0. All right, I did grab a screenshot from the book of the definition of infinite limits, and it's similar to our epsilon delta definition. Looking here, you see that the deltas in the definition, but what we're looking at is the fact that from the left or right of a certain x value, you can approach infinity or negative infinity, and as you have x approaches infinity, you can approach a single value.